Imagine waking up one morning and the sun is simply gone, not exploded, not dimmed, just replaced by a perfectly invisible object with the same mass, a black hole. The strangest part? Earth wouldn't be torn apart. Gravity wouldn't suddenly yank us inward. Our planet would continue orbiting exactly as before, tracing the same path through space as if nothing had changed. The shock would come when you looked up. No sunrise, no daylight, just a hole in the sky where the sun used to be. Only through powerful telescopes would you notice something odd. Background stars stretched into glowing crescents, warped by an invisible gravity well, a pitch-black void bending light itself. Down on Earth, the consequences would unfold slowly, but relentlessly. At first, residual heat trapped in the oceans would delay catastrophe. But within years, sunlight's absence would take its toll. The surface would freeze solid. The atmosphere would begin to fall as snow. Eventually, Earth would become a frozen, airless world drifting through darkness. But black holes are only the beginning. What if Earth orbited other kinds of suns? What would dawn look like under alien skies? And how long could we survive? Picture this. You step outside to greet a sunrise that barely qualifies as one. A dim, rusty glow hangs low in the sky, never climbing higher than what we'd call dusk. Noon never brightens. This is life beneath a red dwarf, a star far smaller and weaker than our sun. Red dwarfs burn their fuel with extreme efficiency, glowing faintly but enduring for trillions of years. They're the most common stars in the universe. But for Earth, the result would be brutal. Our planet would receive so little energy that it would resemble a world relocated to Saturn's orbit. Oceans would ice over, weather would cease, seasons would vanish. Photosynthesis, the foundation of nearly all life, would shut down. Plants would die, animals would follow. Only a few microbial survivors might persist deep underground or near hydrothermal vents, feeding on chemical energy instead of sunlight. Life wouldn't disappear entirely, but it would retreat into the shadows beneath a frozen shell. And colder still lies another failed star. A brown dwarf isn't massive enough to ignite hydrogen fusion. It glows weakly from leftover heat, slowly fading over time. Under such a false sun, Earth would endure permanent night. No warmth, no dawn, just endless freezing beneath a star that never truly lived. Now imagine the sky dominated by a swollen, blazing disk, so massive it fills half the horizon. The sun has become a red giant, its outer layers stretching millions of kilometers into space. The air shimmers with heat. The horizon glows like a furnace. You wouldn't last long enough to admire it. Within a single day, oceans would evaporate. The atmosphere would be stripped away. Continents would melt. Earth would become a scorched, lifeless rock. This isn't fiction. Our own sun will reach this phase in about 5 billion years, likely consuming Earth entirely and scorching Mars into a dead ember. Beyond that, the solar system itself would destabilize. Planetary orbits could shift. Moons could be torn free. Entire worlds might be flung into interstellar space, and even this is modest by cosmic standards. Some stars, like Betelgeuse or UY Scuti, expand to more than 1,000 times the sun's radius. If Earth orbited one of these titans, the entire solar system would be swallowed inside a single roaring envelope of fire. This one is blinding. A harsh blue-white light rips across the horizon. The sky turns violet. Looking up feels painful. The sun has transformed into a blue giant, one of the hottest stars in existence. From day one, Earth would be under siege. Ultraviolet radiation would flood the surface, overwhelming the ozone layer. Stepping outside would be like standing beneath an industrial UV lamp set to maximum. Skin burns instantly. DNA breaks apart. Radiation storms tear through the atmosphere. With Earth now effectively closer than Mercury, oceans would boil away almost immediately. Even metals like aluminum or lead would soften. The ground itself would glow as if the planet had fallen into a cosmic furnace. These stars live only a few million years, a blink compared to our sun's 10 billion year lifespan. Even if Earth somehow endured the heat, it wouldn't matter. The star would soon collapse and explode as a supernova before life could ever adapt. On the horizon now sits a tiny ghostly white dot. It radiates incredible heat, over 1 million degrees, but emits little light. The sun has collapsed into a neutron star, just 20 kilometers wide. At first, cold seems like the main problem. Earth freezes, the oceans solidify, the atmosphere collapses. Our planet becomes an icy tomb, orbiting a stellar corpse. But the cold is only half the danger. Many neutron stars are pulsars, sweeping space with beams of X-rays and gamma radiation. A single pulse striking Earth could fry electronics, shred the atmosphere, and sterilize the surface. These pulses arrive with terrifying regularity, turning Earth into a world trapped between darkness and invisible fire. Worse still, neutron stars are often twice as massive as the sun. That extra gravity would pull Earth into a tighter orbit, amplifying every problem. Now push it even further. Replace the neutron star with a magnetar. The sky erupts in color. Vast auroras stretch from pole to pole, twisting and writhing as if the planet itself is submerged in a cosmic storm. Magnetars possess the strongest magnetic fields known, trillions of times more powerful than Earth's. If one replaced our sun, its magnetic force would instantly crush Earth's protective field. Radiation would pour in unchecked. Electronics wouldn't just fail. They'd cease to function at a fundamental level. Power grids, satellites, medical implants, phones, all gone. Technology would collapse as if physics itself had turned hostile. All that would remain would be the sky, alive with impossible auroras, until you either froze solid or were destroyed by radiation, whichever came first, and that's usually where these stories end. But this time, we're not stopping there. Because stars aren't the strangest neighborhoods the universe has to offer, and Earth hasn't yet seen the weirdest sunrise imaginable. You wake to a sunrise that shouldn't exist. Not one star crests the horizon, but two. Twin blazing suns climbing together, their light overlapping and tangling across the land. Shadows fracture and multiply. Every object casts doubles, sometimes triples. As the day unfolds, a third star rises, then a fourth. The sky floods with gold and amber, and twilight stretches on for hours, refusing to fade. It's breathtaking and utterly unstable. In a quadruple star system, gravity is never quiet. Each sun pulls in a different direction, dragging planets into chaotic paths. Earth's orbit would wobble and twist, yanked like a rope in a celestial tug-of-war. One week, we'd plunge closer to a nearby star. Skies blazing white-hot, oceans steaming, continents baking under relentless heat. The air itself would ripple with thermal waves. Then, just as suddenly, Earth could be flung outward, drifting into the cold. Temperatures would crash. Ice would race across the surface. Any sense of seasons would shatter into randomness. Even if the planet somehow avoided being torn apart, the climate would be unlivable. Summers could feel like standing on molten rock when the stars aligned. Winters could plunge into deep freeze when they drifted apart. Agriculture would fail. Ecosystems would collapse. Life would be forced to adapt not over millennia, but week by week. A sky filled with 4 suns might look like paradise, but beneath that beauty lies endless instability. The sun rises normally, but it hardly matters, because the night sky never truly goes dark. Hundreds of brilliant stars burn overhead, many shining as bright as the full moon. Even at midnight, shadows stretch across the ground. The heavens glow like a spilled chest of jewels, dazzling and alive. This is life inside a dense star cluster. From the surface, it might feel magical, but star clusters are among the most dangerous neighborhoods in the galaxy. Stars here are packed far closer together than in our calm corner of space, and in such crowded conditions, catastrophe is inevitable. Every few million years, a massive star would explode nearby in a supernova, close enough to flood Earth with lethal radiation and shockwaves. Each blast could strip the atmosphere, sterilize the surface, and reset life to zero. Again and again, gravity would be no kinder. Passing stars would constantly tug at Earth's orbit. One close encounter could nudge us just enough to send the planet spiraling away from the sun, or fling it entirely into interstellar darkness. A sky with 1,000 suns might seem like a dream. In reality, it's a cosmic execution. The sun still rises, but it shares the sky with something far stranger. Vast clouds of glowing gas, pink, violet, emerald, stretch from horizon to horizon. They shine brighter than city lights, even during the day. Tendrils of dust curl and twist across the heavens, shifting with every glance. You're inside a stellar nebula, like the Orion Nebula, a birthplace of stars. It looks serene, almost holy. But nebulae are not peaceful places. They are chaotic factories, forging newborn stars that flare violently as they form. Radiation surges through the clouds. Shockwaves ripple outward. Massive stars ignite nearby and burn fast, dying young in catastrophic explosions. For Earth, survival here would be nearly impossible. Radiation would slowly erode the atmosphere. The planet would become more like the moon, airless, exposed, and lifeless. No protection, no future. And yet even this is tame compared to what lies deeper. Now the sunrise looks wrong. The sky appears filtered, washed in strange hues, as if reality itself has been edited. But it's not a trick. The sun looks dim because the background is too bright. You're standing near the galactic center of the Milky Way. Here, stars are packed so densely they blur into glowing clouds. Thousands fill every patch of sky. Darkness no longer exists. Harsh ultraviolet radiation pours through space, strong enough to strip atmospheres from exposed planets. Cosmic rays hammer relentlessly, invisible bullets tearing through matter, damaging DNA, frying electronics. Young stars erupt with flares millions of times stronger than our sun's worst solar storms. Supernovae are common. Gamma-ray bursts, among the most destructive events in the universe, could sweep across Earth without warning, erasing the atmosphere in seconds. With so many stars blazing overhead, faint galaxies and distant signals would be drowned out completely. The sky's brilliance wouldn't just threaten life, it would blind our ability to understand the universe beyond our own chaos. But at the very heart of this madness waits something even more extreme. The sun is irrelevant now. Whether it's there or not hardly matters. The horizon is dominated by a perfect black circle, an absence surrounded by warped rings of light. Entire constellations are stretched into glowing arcs, bent around a void. This is Sagittarius, the supermassive black hole at the center of the Milky Way. It weighs more than 4 million suns. We know star systems orbit monsters like this. Some swing dangerously close. Science fiction loves this idea. Interstellar famously placed humanity near a colossal black hole. But reality is far less forgiving. The accretion disk alone glows with deadly radiation. As matter spirals inward, it releases violent flares of X-rays and gamma rays powerful enough to strip Earth's atmosphere and sterilize the surface. Nearby stars add their own gravitational chaos, tugging relentlessly at planetary orbits. Over time, Earth could be torn loose, hurled into deep space, or dragged screaming into the black hole itself. Long before that final plunge, life would already be gone. The sky would be the most spectacular humanity had ever witnessed. And it would also be the last thing we'd ever see. After all that chaos, we've earned something gentle, so let's leave the sun exactly as it is. Same warmth, same familiar golden rise. Days feel normal. Earth lives on, unchanged.
But when night falls, everything transforms. The Milky Way no longer stretches across the sky as a faint, dusty smear. Instead, the entire galaxy reveals itself at once. A colossal spiral suspended overhead. Its brilliant core glowing like a celestial lantern, spiral arms unfurling outward in vast rivers of stars. From this impossible vantage point, the whole structure of our home galaxy is laid bare. Here, the solar system doesn't live inside the Milky Way anymore. It rests within the small Magellanic Cloud, a neighboring dwarf galaxy, slowly orbiting our own. From here, humanity could study the Milky Way the way we never could from within its disk. We could trace its spiral arms with clarity, map its true structure without obstruction, finally see our galaxy as it truly is, not through inference, but directly. For astronomers, this would be the ultimate gift, a perspective modern science can only dream of. The small Magellanic Cloud is a relatively calm neighborhood. Far fewer nearby supernovae. Minimal exposure to lethal radiation. No crowded stellar chaos tugging at Earth's orbit. Gravity behaves. The night sky dazzles, but it doesn't threaten. After worlds scorched by giant stars, frozen under dead suns, blasted by radiation storms, and torn apart by gravity, this is different. Here, the universe puts on its greatest show without trying to kill us in the process. So after all these visions of destruction and wonder, this is where we finally catch our breath, a sky that is both breathtaking and livable.